Now, today's session, welcome everyone once again to week 2 of AI-powered development with Github Copilot. Last week, we set up Github Copilot. We explored the feature landscape. We got comfortable with the inline suggestions, the next edit suggestions, and wrote our first AI assisted program if you did your hands-on lab 1 and 2. Today, we are going to make a step forward, right? So this week's topic is prompt engineering, Copilot chat mastery, and spec-driven development. So think of it this way. Last week, you learned how to drive a car. This week, you're going to learn how to put the car on speed, right, with a destination in mind. So prompt engineering is the single most important skill for getting great results from any AI tool. So not just Copilot, but ChatGPT as well, Claude as well, Gemini as well, all of them. The quality of what you get out is directly proportional to the quality of what you put in. And also spec-driven development, that's the methodology that ties all of this together. So when you write clear specifications first, then having Copilot implement them, that is how professional developers are working now in this period. So by the end of today, I want us to have a toolkit of prompt patterns, know every chat mode inside and out, understand spec-driven workflows, and should be able to use Copilot to generate exactly what you need on the first or the second try. So today's agenda is packed today. We'll start with the core principles of prompt engineering, the rules that make the difference between mediocre suggestions and excellent code generation. Then I will show you a live demo of comparing like bad prompts versus good prompts. Then next, we'll deep dive into Copilot charts, the 3 modes. I think we've spoken about it, some of them last week as well. So we're going to do it like we're going to do a deeper dive into it and all the keywords and shortcuts that unlock Copilot's full power. Then again, we'll talk about spec-driven development. We're going to talk about, and I'll give you a quick challenge that I want us to do on this call, and I'll give you a take-home hands-on lab as well. All right, so let's dive into prompt engineering. So you hear this a lot, but what does this actually mean for developers, right? So simply put, it is the skill of writing instructions that an AI model can understand clearly enough to produce exactly what you need. So it's the difference between asking somebody, make me a website, than asking somebody, please create a responsive portfolio page with a navigation bar, 3 project cards, and a contact form using HTML, CSS, etc. So we can see the different ask that we're asking somebody, right? So the second prompt is dramatically better with better results, and that we're going to learn today. So now, why does prompt engineering matter, right? If you look at this on top, better prompts means better code. It also means faster development and fewer bugs. So the quality of what Copilot generates is directly proportional, again, as I mentioned, to the quality of your prompts. So if you look at the left-hand side, we can see the bad prompts, and if you look at the right-hand side, you can see the green point. So again, I said last week we spoke about the inline suggestions, next edit suggestions, and wrote our first AI-assisted programs. So today we are taking a massive step forward, and today's week we are talking about prompt engineering, Copilot charts mastery, and spec-driven development, right? So that we're going to talk about today. So basically what it means is that like last week you learned how to drive a car. This week you're going to learn how to put it on gear 1, gear 2, or put it on speed mode, right? So that is what we are going to do today. And this is our agenda for today so that it can make sense to you. So today we're going to talk about the core principles of prompt engineering, the rule that makes the difference between mediocre suggestions and excellent code generation. Then next, we'll deep dive into Copilot charts, the ask mode, the plan mode, the agent mode. Then we'll also talk about something that is new. It's called spec-driven development. It's pretty much new. I think it came out sometime last year. Then afterwards, we're going to do a challenge for like 2 minutes, a friendly competition that you're going to, because I expect everybody to have downloaded Visual Studio Code now. So I'll give you like a challenge that you have to do right on this call, so that I know you're following me. Then we are going to do a quiz as usual, just like last time. You put your answers in the chats, and finally the hands-on labs that you take home or do on the call, depending on your appetite. So now, what is prompt engineering? So it is a term that you hear a lot in AI. Simply put, it is the skill of writing instructions that an AI model can understand clearly enough to produce exactly what you need. So as I mentioned earlier on, there's a difference between asking somebody, oh, make me a website, than, oh, I want you to create a website that has a responsive portfolio page with nav bar, 3 project card, like you telling it exactly what it is you want, right? So the second prompt, obviously, it's dramatically better results than the first one because the first one is vague. Then I moved on to like, why does prompt engineering matter? So if we look at this sort of math up here, right? Better prompt means better code, means faster development. Remember, last week we learned how to drive car. Today we are trying to go faster, right? Faster development time as well, and fewer bugs. So the quality of what you generate is based on your prompting skill. So now I'll just look at these two tasks, this same task, but two different prompts. Can we notice the difference between prompt A and prompt B? I want us to take your time, take a look at it. So look, if you look at the vague prompt, right, it says make a login function. So that's just 5 words, make a login function. So what will Copilot do with it? It will just guess. It might give you a function that takes a username and password as plain strings. It can do a simple comparison that returns true or false. No validation, no hashing. Imagine Copilot giving you an application where users can type the password with that I thing that is there to hide other people from looking at your password, right? So things like that matters, right? Now look at the right. Now you're telling Copilot exactly what to do. Same task to create a login, but this time around you are telling it you take email and password parameters. So it's going to use like regex, for example. If someone put dots, I don't know if we saw the tweet where somebody said they made a mistake on their jam form and wrote .con instead of .com, and they didn't get like an error message, right? So imagine using ChatGPT and just tell it to make a login function. You're not checking if the person put a wrong email address. What should happen? If the person put a wrong password, for example, if the person just put 1, 2, 3, 4, 5, would you just take it? Right? So that is what prompting helps you do, right? Because again, remember, Copilot is your assistant. It's not going to do your job for you. So those kind of things are the things you need to consider when you are using Copilot. So this is the same AIO, same model, same task, but dramatically different results. So that is the entire argument for learning prompt engineering. So this is not just about Copilots. These skills also transfer to, like, again, as I mentioned, ChatGPT, cloud, anything you want to do. You want to make sure that you have prompt engineering skill, right? Let me give you a real world analogy that is not even AI. You hire a contractor and say, build me a house. Then asking them, like, you give them a blueprint, you give them the materials you want to use. Oh, you don't want to use wood, you want to use cement, or you don't want to use this. You give them a timeline. Make sure you complete this in 1 year time, right? So that is the difference between two different kind of prompt engineering, right? So does that make sense? Does anybody have any questions so far on why prompt engineering matters? Okay, no question means we understand why prompt engineering matters. So now, based on the Github official prompt engineering guide, we have 6 principles to prompt engineering, right? So try to memorize this if you can. So the first principle is to start general, then get specific. So don't try to write the perfect prompt on your first try. Start broad, see what Copilot gives you, then you can start adding your constraints. The second principle is to give examples. So if you want an example output format, you can show Copilot what it looks like, right? Example may have like a picture of what you want the application to look like, right? So you may have a picture of it. So you give it an example of like, this is what I want it to look like, right? The third principle is to break it down. So don't ask Copilot to build an entire application on one prompt. So break it into functions and components and modules. So what does this mean? It still means that you also, even though you're using GitHub Copilot to develop, you still need to understand things like what is a function, what is a variable, what is a component, And you can still ask GitHub Copilot to teach you all those stuff as well. But you need to understand those principles to help you architect a good solution. Fourth principle, be explicit, avoid ambiguity. So tell Copilot the framework you want to use, the patterns you want to use, right? And I will show us how to use context tools like at workspace or the file etc. Then the fifth principle is iteration, right? You treat prompting as a conversation, not a one-time shot. So if the first result is 80% right, refine your prompt to fix the remaining 20%. For example, when I'm chatting with ChatGPT, Copilot, or Claude, I ask it again, this answer you gave me, have you checked Microsoft Learn documentation? Rate your answer on a scale of 1 to 10. Then you see Claude rating itself like, oh, I'm going to rate myself 6/10. I think I could have done better here, 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 here. And I said, okay, fix those things you said. It will now fix. And I'm like, okay, technically, rate yourself again. It's not like, okay, I'm going to rate myself 8/10. I still see some gap here. So that is what we call iteration and refining your prompt, right? So you keep on iterating that prompt until you get the solution you want. Then the last principle is to keep your chat history focused, right? If you have a new topic, use a new session for that particular topic, right? I'm going to show us what the sessions look like. So when you have long, wandering conversations, it confuses the model, right? So that is how you undo prompt engineering. Any questions so far? All right, so this is an example of those principles I've mentioned earlier on. So let's look at real examples, right? From let's start from top left, from the principle, the first principle, right? Starting general and getting specific. I can ask Copilot to create a registration function, right? So that is an example of principle 1. This is how expert Copilot users work. They don't try to specify everything up front, they iterate, right? So now when Copilot generates a basic function, your second prompt will be now, okay, add email validation with regex. That's if somebody puts sarahmachi.com, make sure like it's sarahmachi.com, you check those regex, like, oh, this is not normal, it's supposed to be an @, right? If you make a mistake, maybe writing sarahmachi@gmail.com, there's no @ symbol. What is the problem there? So that's what we call validation, to check that, like, okay, this thing is like, is how an email is supposed to be. So most things have validation. For example, car plate number. Each country has its own regex function, right? A Nigerian plate number, we have its own regex. An Irish plate number would have its own regex. I am trying to validate it, right? So an email also has its own regex. Like, okay, in an email, what are the things that must be there? The @ symbol must be there. The domain name must be there as well. So anything you are doing, you need to have a validation with it, right? Then the third prompt, now after the user is trying to get specific, is to add password strength. What do you want the password to look like? Do you want them to use at least one uppercase and give them that check mark? Okay, what is left right now is lowercase. What is left right now is number, right? Or this password does not meet the maximum requirement or the maximum character. So those are the kind of things you want to do in practice, right? Then the second principle, which is giving examples of better outputs. Again, I've already mentioned one, which is uploading picture, right? The second one on this screen is like, I want a function that converts this to this. Instead of just describing the logic, you can show Copilot 3 input output summary, right? So Copilot understands the pattern and generates the exact function that you want. Principle 3 as well, an example would be breaking complex tasks into simple tasks. So instead of build a complete e-commerce checkout for me or build an Amazon for me, you can tell it step by step, create a shopping cart class with add or remove, add calculation to it, create a checkout function to it, add email receipt using SendGrid or whatever it is you want to use, create admin routes for order management. So this is an example step by step on how to break complex tasks into smaller tasks when you are building an application using GitHub Copilot. Remember, the end game for us here is to be able to build an application towards the end of our project. So I'm just showing you how we are going to get to week 7 by doing all these things in practice. Then the final principles is, so let's look at principle 4, avoid ambiguity. So telling Copilot, make a database function You're not telling anything useful. What database are you using? Are you using Cosmos DB? Are you using PostgreSQL SQL query, right? So you want to make sure that you're telling Copilot what exactly it is you want, right? And Copilot will generate the exact working code for you. Then principle 5, iteration. Again, your superpower, ask for a function. Copilot may give you something, but that's not what I need for million items. You start, instead of starting again, you refine it. Use this, use that, add this, add that, right? That's an example of how you refine your prompt. And finally, to principle 6, keep your chat history relevant and focused. So your session 1 can be your React front-end setup. Your session 2 can be Flask API endpoints. Your session 3 can be database schema. That way, Copilot does not have too much things to handle from. Instead, it knows that, okay, this particular session is us doing the database stuff. Let us undo this particular database they were doing in this particular session, right? So let me just move to Visual Studio Code so we can see it working. All right. So, can we see my screen? You can see my screen, right?
Yes.
Okay. All right, good. So now when I spoke about session, this is a session. We can see this particular session as file content inquiry. So now if I want to do, I know I'm trying to do like a demo with textiles, right? So I'm not going to use the same session that I used to build a function for calculating things, right? I'm going to create a new session, right? A new chat. So when I click create on new chat, automatically I'm not going back to this session. You can see the session is already different. So I go back and click new chat, right? So I'm new chat and I'm going to start asking questions or try to build something. That is what I'm talking about, like, using multiple sessions. So this one can be a database session, and I talk about database with this particular agent, right? So that is how you use sessions when it comes to GitHub Copilot. Now let us do like let's see what 2 prompts would look like, right? So let me create a prompt and call it bad prompt.py, and let's create a new one and call it good prompt.py. Let's see the difference it makes. Now I'm going to tell Copilot to, as we did in our last class, make a calculator. Now I'm going to tab. I don't prefer it in this one. Let me use the chat mode. So let me use the chat mode to create this. So I changed from ask to agent. I'm going to talk about this shortly as well. And I'm going to tell it, oops, make a calculator. Make a calculator. Let me add this context. So let's see what happens. So I'm going to ask it to make a calculator. Let's see what it's going to do. It's thinking. It's going to take a while. No, I don't want to use that. No. Sorry guys, let me just delete this. I've already created this before. So I don't want to use the old stuff. So let me create a new chat, new session, and ask it to make a calculator. Ignore other files. And for the good one, I'm going to give it another one. Demos. Oof. All right. So now it has created a calculator for us. And now let's try to see how it makes the calculator for us. So it just did a definition of a function. So now let's see what difference it will make if we try to give it more things to do. So I'm going to create a new session and tell it to create a calculator class that supports add, subtract. So you can see I'm giving it more information for the good prompts, but let me tell it to also ignore other files as well, so it doesn't collapse with the other file I had. Ignore other files. So let's see what happens. So we can see it generating the code. And let's see what happens when it comes back. All right. Now, let's check the difference between the bad prompt and the good prompt. So for the bad prompt, it just defined a function for us, and like it didn't give us a class. There is no validation, nothing whatsoever. But if we look at the good prompts, it was able to give us like some classes, some validations, right, to validate the number. So must be a number. For example, if I try to impute in the calculator, if I try to impute something that is not a number, it's going to be like must be a number, right? So these are the this is the example of what's like the difference between using a good prompt and using a vague prompt is in GitHub Copilot. So sorry about the mess up. I have already done this before and I didn't want it to like use that same example that I've used. So do we have any questions so far on what prompting is all about?
Yes, good morning.
Okay.
Yes, thank you, Sarah. Good morning.
Yeah, good morning. I can hear you. Yeah.
Yeah, so I have some question. The first one is on the demo that you just showed to us. There is a bit of a JavaScript-like that thing after the def init. Yeah,
Initializing
after
a
the def.
variable. Initializing a variable. Go on.
Yeah, I know. After that, the arrow and the side pointer. Is there any replacement? Is there any other way to write it? Because I don't seem to. What I mean is, for example, here where it says def init, initialize it. I thought that arrow, is it equivalent to return?
I don't think so. But again, the good thing about Copilot is that you can always ask it to explain. So now let's ask it to explain our code. So I'm going to change this to ask. So what was your question again? I was going to cover this, but
I want to know. I want to know why it's using that symbol rather than say return, because it seems a bit vague.
The symbol.
The dash and the
rather than what? Return.
The conventional return or something.
Okay, let's ask Copilot and see why it's using that. Again, this is an example of using GitHub Copilot, right? So if you don't understand why it uses a particular code or you want to make a particular changes, you can choose between the ask, the plan, and the agent. I'm going to talk about it shortly as well to ask it. So it doesn't make any changes right now, right? So it's giving us an answer. In Python, this in a function is a type hint for the expected return type, not the actual act of returning a value. So it's giving us example of why it is using that. So they serve different purposes. Return value is runtime behavior that actually exists the function with a result. Why this is for type checking, editor help, and readability. This is why your method uses both this and return results in the body.
Okay.
So that is, again, using GitHub Copilot to be able to read your code, understand your code, and make changes yourself. This is part of the principle we're talking about, reiteration, asking the question. If this was wrong, we would have changed it as well. Like, okay, I don't want you to use that type. I want you to use return for this particular line of code. Does that check out? Does that make sense?
Yeah, absolutely. And then my second follow-up question is, I saw something around on the new chat where it say you should use /skills. Is the skills different from the plan agent? Because if you look at the very top, on VS Code. No, at the very, very top of your VS Code, where your mouse is, just very close to the top side where you have AI powered. They added a new feature.
Mm-hmm.
They
These are
added a new
the okay. Go on. Ask a question.
Yeah,
Mm-hmm.
they added a new feature where you can toggle between your VS Code and
Mm-hmm.
a chat bot of a sort. Is that also meaning that we can use this sort of chat in that agent? Because it seemed a little bit confusing when I was, as you were saying, when I was trying to check it out yesterday. Where I'm referring to is, you see the very place at the very top at the topmost part of your screen where you have file, edit, selection, view, go towards your left, towards your right hand side. Yeah, you're already there. Just
Yeah.
after that
So
place.
I spoke about it in the class as well. There are different ways to communicate with GitHub Copilot. You don't have to
Okay.
use that chat mode. You can also chat with it in the code as well. But I just
Yeah.
prefer to use that other one. So there, you can use an inline. I spoke about it last class. You can use the
Yes, you did.
inline chats as well to be able to like tell Copilot what it is you want to do, right? Here as well. So you don't have to use that Copilot chat mastery page, but I prefer to use that. So depending on what you prefer to use.
Okay. Yes, but beside the chat, they also
Mm-hmm.
now added a new button again. No, no, no,
Mm-hmm.
no. Just after it, if you go towards your right. No, no, no. Yes, yeah, exactly. Open AI agent, exactly.
Yes, it's
So,
a new feature for where you can pick a workspace. So this is still new. I've not played around with it, but I'll get back to it for next class as well. So it's a new
okay,
feature. It was created sometime a few months ago, but I'll come back to you with this on this
okay.
as well. Yeah, it's a
Thank
new
you.
feature. Yeah, it's a new feature for GitHub Copilot that you can just use. But I still use the old method, which is this. Um, so I will get back to you on this and tell you what it's all about. I've not played around with it, but good this thing, good shout outs. I'll come back with you on it. So any other
Okay.
question? All right, let me
No,
go
not
back
at
to
all.
my, okay, let me go back to my chat mode then. All right. So and that's what I wanted to cover on the prompt engineering side of things. Then I want to talk about the modes that we've just made use of just now. But again, I'll show us what it looks like. So now Copilot Chat has three modes, and understanding when to use each one is critical. So one is the ask mode. So ask mode is like when you are trying to understand again the code that a senior developer must have written, or you're trying to understand the code base or a workspace. An example would be um, this particular code base. We can see it's a lot of code, right? Yeah, that somebody has developed, right? As a junior developer, you may not understand what is going on here. A lot of things going on here. So you can easily change this agent mode to ask mode and ask it about like this particular workspace. What does this application do? Or what is the problem this application is trying to solve, right? So that's for the ask mode. Is your learning and exploration tool. It is read only. It reads your code. It doesn't change anything. So use it when you want to understand the code, learn a new API, debug an error message, or explore your code base, right? Um, so Ask mode is safe. You cannot break anything. Use it freely. Then we have plan mode. So plan mode is like your architect. When you have a complex task, your plan mode will create a detailed implementation plan, which files to create, which to modify, which step to take in what order. You review the plan and adjust it when needed, right? So an example of how to use plan mode would be like someone should give me a quick example that we can just do quick of plan mode to plan something. Okay, nobody. All right, so let's plan to build a calculator. Let me close the one that's already built. Built this morning. Build a calculator using HTML and Python. Right. So this is the plan mode. So again, I already showed you an example of ask mode. I asked it questions when the question was asked in the chat about like, oh, why are we using this stuff return? So same thing again with plan mode. It's not going to change anything. It's just going to help you plan like what you want to build. Then you can keep on iterating using that 6 method I told you about until you are okay with that particular plan before you now build the particular application. So that's how plan mode work. So it's currently inspecting our workspace. It's not going to find anything because we did not do any calculator, right? Any question? Somebody went off, miss. Okay. So that's for plan mode. Then for agent mode is the executor. It can edit your file. It can create a new file.
Which toy? Why is Jaden crying? What toy is he crying for? I thought you were crying for this one now.
Please mute yourself. Thank you. So agent mode is the executor mode.
Okay,
I think, who is that? I think I should.
Yeah, Tunde, please mute yourself.
All right, Chisom, do you have a question? Your hands are up.
Apologies, it's an old hand.
Oh, okay. All right, so agent mode is the executor. It can edit files, it can create new ones, run terminal command, install packages, run tests, right? So that's what an agent mode is all about. So now when you are trying to, let's go and just do a quick demo of the 3 modes again. Let's play around with it. So this is a plan mode I was asking about, build a calculator with HTML and Python. So now it's asking me more questions because I did not give it proper prompting, right? So it's not asking me, do I want this or do I want pure Python scripts or do I want Python script in browser? So I'm going to choose the Flask web. So it's asking me, do I want a basic calculator, a basic plus scientific calculator or custom this thing? So I'm going to choose basic and scientific. Again, we are still in the plan mode, right? So we're still trying to create a detailed implementation plan of building a calculator, right? So it's going to come back. And once it comes back with its answer, that's giving me a plan right now. So now it's left for me now to read this plan. Am I okay with this plan, right? And I'm going to start implementation. So I can either start implementation here, or I can change to agent mode and be like, start implementation. Implementation. So now the agent mode is now going to try to look for the best tool to use and try to edit the file. So again, ask mode, read only, for you to learn, for you to know what's going on. Plan mode, for you to research and plan before executing. Then agent mode is to create. So we can see the to-do list that's given itself. It's going to build a backend API. It's going to build an HTML calculator UI. It's going to add JavaScript integration, responsive styling, add dependencies, and verify. So it may take a while, so I'm not going to dwell on it. When it's done, I'll bring it back to our screen. But do we have any questions about the different kind of modes that we have spoken about so far? Okay, no questions. Then, so again, I think I spoke about the inline chat last time, but just to reiterate again, it's for small edits. You can select some code, control it, and a small chat box opens up and you can edit it in front of your editor. However, I prefer using the chat mode than the inline chat. So everybody has their own preference as well. So you can also have a quick chat and some smart actions as well. Now, let's go to keywords and patterns. So the real power of Copilot chat lies in the keywords. So let's go to the chat participants. Let me go back to our demo. Let's see. Okay, now we can see now in agent mode is already running some command, but see where it's trying to, again, it's an agent, right? So it's looking for a human in the loop, like, am I going to allow? So now left for you now to be like, allow all commands in this session, or only allow this particular session, or you can configure auto approve, which means anytime the agent wants to make the changes, it should make the changes. So I'm going to allow all command in this session, so you can just be running the commands on its own. So now let me go to, it's already having errors. It's going to fix it itself. Don't worry. So let me open a new session while that is still working. New session while it's working. All right. So Allow all commands. All right, new charts. Now, let me go back to before I go back to Visual Studio Code, let me explain this to you. So, if you want to scope your question, right, you want to tell Copilot where to look, you are going to use this at workspace. So at workspace indexes your entire project, all the files, all the folder structure, all your imports, all your dependencies, right? So you can always ask a question like, how is authentication handled in this workspace, right? It's incredibly useful when you're new to a project. And that thing again, you can check as well is at your terminal. So this focus on your terminal, like explain the last error. It reads your terminal history, explain what happened much faster than Stack Overflow. Then the last one is at GitHub, right? So with at GitHub, you can search your GitHub repos. Again, if you are signed in, you can search your GitHub repos, searches GitHub global repo as well for documentation. It uses GitHub as its external knowledge, right? So what are the best Python libraries, for example, for PDF generation? So the kind of questions you can ask it. So let me just show you what this looks like in our code. So I'm going to go to this auto dash. I'm going to close this. I close this. All right, so I'm going to go to this and use the at function. So at workspace I just spoke about. At workspace. At workspace and how is authentication handled in this project? I hope it works. Skip. So we can see now it's coming back with like searching the whole code base for authentication related code. It's reading everything and it's going to come back with an answer again in the ask mode, right? So that's how you're going to use it. Like if you want trying to use the ask mode, trying to ask questions on the entire work base. Additionally, right, you can also limit this to not just the workspace. You can limit it to a particular file. If you are trying to ask question, to explain something, to fix something, to dex something, to generate a documentation, right? So you should know, you should be aware of these kind of key commands as well to use when you are building a full-blown application that would help you, like, fix things or clear things. So these are the most common ones that are being used right now. If you want to reference a particular file, if you want to reference your entire code base, this is how you're going to go about it, right? So do we have any questions about the keywords and context? Okay. All right. So the next I want to talk about is using images in Copilot chats. If you're building an application, you may use Figma for your sketch or for your mockup, and Copilot will now generate the matching HTML or CSS file, right? So you just have to screenshot a design from your Figma, or your product designer person gives you the mockup, and you can start from there to build your application, right? That way, I don't know if you noticed that sometimes I don't know if you guys have noticed, but I know when it's GitHub Copilot that create an application, the UIs are similar. I know when you use Claude to create an application or PowerPoint, you can see my PowerPoint, it is kind of similar. You would know. But when you now use your own mockup, like, okay, I want this is how I want my PowerPoint to look like, right? This is the image of what PowerPoint should look like. This is the image of what my application should look like, right? So that is much more different. You are trying to create an application that is your own and not just the generic AI kind of application, right? Even if you get an error, for example, you are doing a test on the web of the particular app you are building, you can screenshot that error and paste it in the chat and ask Copilot what is causing this error. And this is where you do it as well. In the chat right here, you can always paste an image in this place. You copy the image, and you paste the image right here. That is all you need to do. And ask Copilot your question, like, based on the screenshot of this, based on the error on this screenshot, how do I fix these particular things as well? And that way you can do it as well is, again, paste a flow chart or diagram, right? You can always paste a flow chart or diagram and ask Copilot, what is this about? We can just do a quick example anyway while we are here. So let me just take a screenshot of this and ask Copilot what this is all about, right? So I've taken a screenshot. I go to my Visual Studio and I paste the screenshot there and I ask it, oh, new session, paste the screenshot, ask it, what is this architecture about? So based on the screenshot, it's going to give me an answer what the screenshot is all about. So same thing, imagine you have an error, you're writing a PowerShell script, you have an error, you can always paste the error, right, on GitHub Copilot, and GitHub Copilot is going to like read the diagram and ask more questions if you want to ask more questions and tell you about it. So you can see the answer it gave me. It gave me in plain English. It's showing a customer request handled by multiple specialized AI agents, blah, 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 right? So that's an example of how to use images in GitHub Copilot chat. Any other question? Any questions so far? All right. So how this works under the hood is because the image support requires a vision capable model. So GPT-4o and Claude support this. So if you use a model, like you select a model here, right, that doesn't support images, it's not going to work. So your GPT supports it, your Claude supports it. So that should handle most of your use cases anyway. And that's how it works under the hood. Now, there are 6 patterns that I want us to understand from prompt engineering. So we have the role pattern, give Copilot a persona, act as a senior Python developer, do this and do that, right? That's what you should know. When you're trying to talk to GitHub Copilot, give it a persona, a kind of role for your this thing. So I want you to act as a senior Python developer to build this stuff for me, right? You can also put constraint as well, set boundaries, the allowed library, the coding style. Again, they all follow the same principle. Template pattern. If you have a template that you have in your organization already, you can provide that template to GitHub Copilot, and GitHub Copilot use that pattern as well. We have the comparison pattern. Ask for multiple solutions. Show me 3 ways of doing something, right? Then you can now choose amongst that particular pattern GitHub Copilot gave you, right? You can also mix and match these patterns together. Like you're a code reviewer, analyze this PR for bugs. You're a tester, test this PR for me, right? We also have the step-by-step pattern. Walk me through this step-by-step and wait for my confirmation, right? So there are different patterns on how to build an application using GitHub Copilot. Again, remember, this is for people that have not built any single line of code before. So if you don't understand this pattern, how would you know that GitHub Copilot is not just giving you rubbish? Okay, so these are the common mistakes that we've seen people use. Too vague, too much at once, no context, never iterating, and stale chat history. Because of time, let me move to spec-driven development. It's kind of a methodology that ties everything we've learned together. So spec-driven development is the practice of writing clear, structured specifications before you write code, right? When you give GitHub Copilot a well-written specification, you get better results, right? So this was created sometime last year by some open source people. I will share us more links on this in the chat later on today. So spec-driven development is writing a structured specification, defining what to build, defining the behavior of what you are building, defining the constraint of the building or what you are building and edge cases before writing any code. Then you give that speculation or that spec to Copilot and let it implement it. So it's similar to planning as well, right? But this time around, you already know what you want to do. You can start planning from your speculation, from your specifications. I don't know why I keep saying speculation. From your specifications, and you and plan, keep planning together before you start building that stuff, right? So this is an example. The same contractor example I gave you earlier on is what you are going to use for this. You ask a contractor, oh, build me a house. Or you ask a contractor, oh, my house, it has to have 3 bathrooms. It has to have this and it has to have that, right? It's similar to prompt-driven development as well. But this one, you are giving it more specifications on what you want. So how does this work with GitHub Copilot? So the first step is to write a specification. The second step is to feed that specification to Copilot in plan mode. So Copilot read that specifications and create an implementation plan. So how do you implement? You implement with agent mode. Copilot writes the code that fulfills your speculations for you. Then step 4 will be for you to validate against your specification. Is it meeting that requirement I asked it for, right? Is it meeting that requirement I asked it for you? So you validate it again. Then step 5 will be to iterate on the gaps only. If Copilot made a mistake, let's make this, let's change this together, right? And also, just so you know, Copilot can also help you to generate your spec, right? So in case you don't have anything in mind, you can keep talking to Copilot over and over and over and over and again until you are satisfied with the specification it gives, excuse me, it gives you, right? So that is an example of spec-driven development. So I'm kind of being cautious of time here. So now I want us to open our Visual Studio Code. Do we have our Visual Studio Code open? How many of us have our Visual Studio Code open? How many of us have our Visual Studio Code open? I'm not getting a response. So are we still in this class? Okay. So for the next challenge, I want us to write a prompt or a mini spec that generates the best possible implementation of a password strength checker. So I'm going to give us 2 minutes. By 12:02, I want you to paste the prompt you use in the chat. So 2 minutes, 12:02. Open your Visual Studio Code and give me the prompt that you used. If your Visual Studio Code is not open as well, write the prompts that you would use to give Visual Studio Code to help you to generate this particular this particular assignment I'm giving, not assignment, classwork. If you have it open, fine and good. If you don't have it open as well, fine and good. So 2 minutes, you have 1 minute left. All right, time's up. So let me see what we have in the chat. Nothing. Oh no. Time's up, guys. Submit the prompts. Let me see. Don't worry, you don't have to be, your answer doesn't have to be the best answer. I just want to make sure that we're following this class. Just one prompt though. Are you guys reiterating? I just wanted us to show us one prompt. Okay, nobody. All right, I'm moving on then to the quiz before our hands-on lab. So at least everybody should be able to, whether you have Visual Studio Code or not, be able to answer this question. So for question 1, what is the answer? What prompt engineering principles suggest showing input and output examples? I gave us 6 principles. So which of the principles would you say suggest showing input and output examples? What's the answer? Do we have access to the chat? I'm just going to call
Yes,
out names now.
yes, we do. Yes,
So I'm
we
just.
do.
Oh no.
So why are you not putting the
No,
answer in the
not
chat?
everyone. No.
My own.
We don't have access to the chat for me. I don't have
Oh,
access
we
to
don't have access to the
I
chat.
don't have access to it here.
Okay, all right. Okay, then I guess we'd have to guess the options then. So if you are for A, raise your hand. Use any emoji. Okay. If you are for B, use any emoji. All right. If you are for C, use any emoji. So put your hands down so I know. If you are for D, use any emoji. Okay, so yeah, the right answer is give examples. I spoke about the prompt engineering principle earlier on. If you are showing copilots the different examples, right, that is the one that suggests input and output. So question 2, which chat mode should you use to understand unfamiliar code without changing it? If you are for A, use any emoji. If you are for B, use any emoji. If you are for C, use any emoji. Okay. And if you are for D, use any emoji. All right. So yes, the answer is C, ask mode. The next question, which / command generates unit test for selected codes? I think the answer is straightforward. If you are for A, let me see your hands up. If you are for B, C, what of D? Yeah, the answer is D, test. All right. So question 4, in spec-driven development, what do you write first? A, the code, B, the test, C, specification, D, the prompt. If you're for A, let me see your hands. If you're for B, C, and D, the answer is specification for spec-driven development. All right. And finally, what is the main advantage of using spec-driven development versus just prompting? 1, it's faster. 2, it uses less AI. 3, measurable completeness. 4, no iteration needed. If you're for A, let me see your hand up. If you're for B, let me see your hand up. If you're for C, let me see your hand up. If you're for D, all right. So the right answer is measurable completeness when you are using spec-driven development, because your spec is your checklist, right? So you can verify every requirement is met. Okay, so finally, the key takeaways from today's session is 1, prompt quality determines your output quality. 2, the 6 principles are your toolkit. 3 modes, three modes for your 3 workflows, that's your acts, your plan, and your agents mode. Then 4, keywords are your power up. Then 5, we spoke about your SDD that changes this game. So next week we are going to do more of agent mode. We're going to try to build some things, autonomous coding as well. We're going to do some debugging and do some more technical applications debugging and documentation as well. So we're going to move further. We're going to drive the car further. So first set was just introducing you to what GitHub Copilot is. Second class is just me understanding where you are at and how to prompt. So our next class will now start building something towards week 7, slowly by slowly. So I would share this documentation with you as well. Then your hands-on lab. So this is the hands-on lab I want us to do. So I'm giving you 2 hands-on lab. One is to debug a buggy code base with charts, right? I'm going to send a link because most of you are not submitting assignments. I'm going to send a link where I want us to be submitting our assignments, right? Because this also matters to be sure that you're understanding what I'm teaching you. So the first hands-on lab is for you to debug a buggy code base with charts. So first of all, you're going to create a Python function that generates a buggy code. And the second part will be to fix that bug as well in that particular code base and show me a screenshot of 1, the buggy one, and 2, you're fixing one. Then the second hands-on lab we are going to do as well is to create an MD file, a README file for your spec, right? You can use Copilot to create a spec file for you as well. So any application you want to build, create a spec for it and submit it to me as well. I'll give us a link of where I want us to be submitting our assignments to. Do we have any questions before I call it a day? Let me stop sharing my screen.